And welcome back for the first video in this final module here in our wells hydraulics course. So this module is on pump and treat. So a couple of videos on this and then a couple of videos on a mud flow example. So here I'm just introducing pump and treat. I've already talked about it a little bit. Again, we're continuing with our multiple wells system. So we've seen dewatering right before this, and now we're going into more of the environmental engineering side of the industry, where typically we use multiple wells to isolate a contamination, a plume in the ground, and then pump it to the surface, treat it, and then re-inject. So again, this is basically the illustration you have here on the left-hand side, where you can have these pumping extraction wells essentially that send the contaminated water into some treatment facility. So it can be a train of treatment processes or, depending on what the situation is, and then inject the clean water with an injection well here back into the subsurface, or sometimes just discard the cleaned water to some surface waterway, right? So rivers, lakes, etc. Once it meets code. Note that you have some monitoring well here. Here there is the extent of the capture zone. So this is an important concept that I'll talk about in the next lecture. I will explain how we calculate capture zones and exactly how we design essentially wells so that they capture all of the pollution that is in the ground. Here, just as a reminder, on the right-hand side, I'm just showing a well pair, similar to what we've done, right, with our little Excel finite difference Excel models, where you can see there's an extraction well here, an injection well here, and again, you can see easily how we create a cell underground, right, where there is a recirculation cell, if you will, that can capture essentially the water in that zone here. Okay, here's an example of the Paducah plant. So this is a large site. This is many hectares, tons of acres, and this is a classic, I guess, example where you have the Ohio River here. The site itself is right near the confluence of the Ohio and the Mississippi, right over there, and you can see here a plume of TCE, which is trichloroethylene, and essentially this is like used. So this is like a quite volatile organic compound, right? Used as a essentially degreaser, right? So all those almost like alcohol, if you will, or some of those chemicals that you would use to degrease, right, in industry. So this is a brown site that has been cleaned up essentially, or that is being cleaned up by the Department of Energy, and you can see here the site. So this is again a top view in Google Maps where you can see the extent of the site itself, right? All the different buildings, right? You can see the top of the buildings and the extent, the fields, etc. So that gives you a sense of scale essentially of that site. And then here on the right-hand side, you can see here is a shade of the plume that is being cleaned up. So it's, well, all the plumes are being cleaned up, but it's just a shade to show you that underground there's something. And this is actually the surface building where the pollution is being treated, right? So again, it's a pump and treat operation. So they're pumping, TCE the TCE plume from the ground, treating it in that building, and then reinjecting. And again, here you can see on the bottom, 2020, right, the receding plume essentially, or the fact that it's been, extracted from the ground, treated, and then the clean water is just putting out. So this is a, concrete example of a pump and treat operation, large-scale pump and treat operation. And again, you can find more documentation if you're interested to see exactly the details about this site. So I was talking about the capture zone, and this is really an important concept. So the next video lecture will be all about the capture zone. So here you have a well pumping, and you can see that if we use our little Excel model that we've used before, you can see all the flow lines here, right, coming into the well, and the well is here. But of course, from the backside, so the regional flow is this way, right? Here, right, we're capturing, you can see this flow line here. So there's only so much we can capture. We can't capture as much, right, on the downstream, right, from here, than we can from the upstream. So from the upstream, we can capture all this plume, essentially. But from the downstream, let's say if there was pollution here, we can't really pump it with this well. So calculating, you know, how far, and that's valid on the sides too, you know, calculating how far exactly can we pump with a single well or multiple wells, you know, what is the extent again, right? If your plume is completely encased here in that cell, that's good, right? Now we're going to actually be able to clean it. But imagine we had, you know, pollution out here, then we're not pumping it. So that's a problem. So again, calculating the extent of the capture zone is really important. And this is just the same in a side view, if you will, right? This is your well that you're pumping out. And again, there's water rushing into this well here, right? But of course, here again, there's a limit on how far downstream you can actually pump backwards, right? Okay, I think this is it for this broad introduction. Again, I'm going to do one lecture on capture zone in the next video. Thank you.